Look closely at the physical properties of these two chips. One snaps clean, dry, pale, and chalky. The other shatters, leaving behind a thick, glossy layer of orange dust. Both snacks are manufactured using the exact same three foundation ingredients: corn, oil, and salt. Yet the store-brand chip costs $1.49, while the premium bag costs $4.29. That price difference pays for what happens to the surface. While the cheap chip receives a single pass of spices over leftover frying oil, the orange residue on the premium chip is a highly engineered, multi-layered adhesion system. This cross-section shows the invisible architecture required to make that powder stick. The exterior relies on two dedicated oil applications, three separate physical adhesion forces, and a powder manufactured with an embedded chemical glue. It is the same corn, the same fryer, and the same grocery shelf. The manufacturing sequence between the hot oil and the sealed bag exists as a calculated system designed to force a powder onto a surface that naturally repels it. This is Disneyland in the early 1960s. A salesman from Alex Foods worked a concession stand here, watching staff throw away unsold tortillas every night. Inside this restaurant, Casa de Fritos, he convinced the cook to salvage the waste. They cut leftover tortillas into triangles, fried them, and added seasoning. Customers bought them faster than the kitchen could produce them. A Frito-Lay marketing executive named Arch West tasted the snack and recognized a gap in his company's portfolio. Frito-Lay owned corn chips and potato chips, but nobody had scaled a tortilla chip for a national market. Frito-Lay brought the process in-house, shipping the product to grocery stores nationwide in 1966. The original chip was launched plain, unseasoned, and labeled toasted corn. Outside of the American Southwest, consumers found the plain chip bland. Sales stalled. To help the snack survive across regional lines, Frito-Lay realized they had to apply heavy flavors, introducing taco seasoning in 1967 and nacho cheese in 1972. While flavor was a business necessity, trying to apply dry powder to this specific fried dough triggered an engineering roadblock that would take decades to fully solve. The root of that problem traces back 3,400 years to a technique invented by Mesoamerican civilizations called nixtamalization. This process requires soaking dried corn kernels in water mixed with calcium hydroxide. The alkaline solution dissolves the kernel's outer hull so it can be ground into dough, producing the distinct warm aroma of a modern tortilla. The factory rolls this chemically treated masa out to a strict thickness of 2 millimeters, stamps it into triangles, and subjects it to a 16-second pre-bake. This sets the physical skeleton before it hits the fryer. Exiting the 375-degree fryer, 80% of the oil initially rests on the top surface as liquid glue. As the masa cools, a pressure vacuum pulls the oil into hollow microscopic chambers, draining the surface completely dry before seasoning. The exact alkaline reaction that allows the corn to form a dough guarantees the final structure will act like a sponge, rejecting external powder. Standard single-stage coating systems work for dense potato chips, but they failed on this porous dough. Frito-Lay had to look outside traditional food science to fix the flaw. They found the answer in medical manufacturing. The tumbling drum used to coat these chips is a pharmaceutical coating pan, the exact technology used to layer medication onto ibuprofen and aspirin. Inside the drum, a manifold sprays a second coat of liquid oil. As powder enters, electrostatic charge and van der Waals forces pull particles toward the oil. Capillary force then drags the powder deep into the microscopic masa crevices, mechanically trapping the flavor. Securing cheese powder to a tortilla chip relies on the same physics used to coat a pill, ensuring the coating doesn't fail before it's consumed. Maltodextrin provides the final layer of adhesion, a built-in glue engineered directly into the powder that is specifically formulated to activate upon contact with the oil. As the newly coated chips pass through a cooling zone, the surface drops in temperature. The liquid oil transitions into a solid state, locking the maltodextrin in place so the powder remains stable inside the bag. When you pull open the foil seal, the immediate rush of corn and cheese hits you. Those volatile aroma compounds are designed to escape the package the moment it is opened. The chip feels dry to the touch, but on the tongue, saliva immediately dissolves the maltodextrin shell, liquefying the solid oil anchor. This structural collapse forces the flavor to release in a strict sequence. The short-chain molecules of salt and acid register immediately, followed milliseconds later by the longer-chain molecules that register as cheese. Dense potato chips, or basic crackers, hold frying oil so effectively that simple, dry seasoning bonds on contact and remains stable when handled. The orange dust left on your fingertips is the result of an intricate, moisture-activated pharmaceutical coating touching human skin. It dissolves exactly as engineered.